When we meet a nonlinear system and we're trying to select a method, we should prefer to use elimination if we possibly can, because that's going to typically eliminate some nonlinear terms, which is going to make our lives easier. If we can't use elimination, we should try substitution, as long as we can actually solve for one of the variables. Sometimes we can't. And sometimes it's very messy to do it. For example, we might need to use the quadratic formula, and that doesn't sound like a lot of fun if there's other variables in the equation. So, elimination if it's possible, substitution if we can solve for one variable. If solving for one of the variables gets too messy, or we just can't solve for one of the variables, we'll use numerical methods of the kind that we meet in calculus. So in this course, we aren't going to meet any systems that we can't solve either by elimination or by substitution, but be aware that those are out there. So let's take a look at this example. Here we have a system of nonlinear equations, and we might look at this and say, oh, hey, look, I have an x squared here and a negative x squared here. I'd like to try to use elimination for this. Unfortunately, we can't do that because equation 2 lacks this xy term. So we could eliminate the x squared term, but we would still have an xy term, which means there would still be an x variable in the equation. So that wouldn't actually help us. Instead, we're going to try to solve this by substitution. Substitution also has a disadvantage here, though. Notice that both of my equations have both of the variables squared in them. I'm going to choose 2 because it's easier to work with, and I'm going to try to solve that for y. Watch what happens. I'll add negative x squared to both sides, and I get y squared equals x squared plus 5. That's no problem. But then if I want to get y, that's plus or minus the square root of x squared plus 5. So we've got this plus or minus here. That's actually 2 different values of y. But I'm going to just plug it in with the plus or minus, and we'll see what happens. We're going to plug equation 2 now into equation 1. So x squared, I'm going to leave alone. And then I have x times y is equal to this thing. So plus or minus the square root x squared plus 5. Plus. Now, this is a trick that's going to sometimes be useful to us in solving nonlinear equations. I have a y squared here, and I know what y squared is equal to. Y squared is equal to x plus 5. So I can replace y squared by x squared plus 5 without going through taking the square root and then squaring it again. That would get me back to the same place, but I can just use y squared directly, which is going to save me a little bit of work. And then that's equal to 19. Okay, so I'm sitting here looking at this equation, and we know what kind of equation that is, right? It's one of those equations that has a radical in it and also other variable terms. So we get the radical term alone on one side, and then we square both sides. So I'm going to leave my radical term on the left. I'll have x times plus or minus the square root of x squared plus 5. And then I'm going to subtract everything else from both sides. So I've got a 2x squared. I'll subtract that from both sides. And then I have a 5. I'll subtract that on both sides. So 1x squared and another x squared and a 5. That's everything. Okay, so now I have my radical term on the left. I could divide both sides by x right now, but then I'd get something with an x in the denominator, and that doesn't sound like much fun. So I'm just going to go ahead and square both sides as is. Square the left-hand side, square the right-hand side. On the left, I square the x, and then I square that square root. Notice that when we square the square root, we get rid of that plus or minus, because whether it's positive or negative, when we square it, we get the same result. On the right, I have negative 2x squared, all squared. That'll be 4x to the 4th. Then I'll have 2 times negative 2x squared times 14. That'll be minus 56x squared. Plus, then I'll have 14 squared, which is 196. Okay, that's not too bad. This could be worse. I've got x to the 4th plus 5x squared equals 4x to the 4th minus 56x squared plus 196. Subtracting everything on the left from both sides because this is a polynomial now. I'll have 3x to the 4th minus 61x squared plus 196 equals 0. Oof. Okay. I certainly hope I'm going to be able to factor this. Let's try it. I'll have a 3x to the 4th and a positive 196. And now I want to get two numbers that add up to negative 61 and that multiply to the same thing as 3 times 196. I haven't done this in a while. Let's recall how to get our calculator to help us with that. I'm going to load up my table, and I want to have two numbers. I'm going to call the first one x, and then the second one is whatever I need to multiply x by in order to get 3 times 196. So I'm going to take 3 times 196 and divide it by x. And then I think if I want to add up to negative 61, they have to both be negative, so I'm going to scroll upward. And I'm scrolling upward looking for a negative 61 in the y column. Oh, there it is. Negative 61 in the y column. One of my numbers is negative 12. And then to figure out what the other one is, what do I need to add to negative 12 to get negative 61? It's negative 49. So I have a 3x squared is my greatest common factor here, times an x squared. Here I'll need a minus 4. 3x squared times negative 4 is negative 12. Then x squared times negative 49 is negative 49x squared. And negative 49 times negative 4 really is 196. So this factors as 3x squared minus 49 times x squared minus 4. So I could have x squared is 49 thirds. So x is plus or minus 7 over root 3. I could simplify that radical, but I'm just going to leave it like that. x squared equals 4, so x is plus or minus 2. Okay, so that's 4 different x values. And to find out the corresponding values of y, well, y is one of the square roots of x squared plus 5. So if x is 2, y is one of the square roots of 9, so it's plus or minus 3. So that gives me 2 possible solutions, 2, 3, or 2, negative 3. If x is negative 2, then again, y is one of the square roots of 9, so it's plus or minus 3. That gives me 2 more solutions. Negative 2, 3, and negative 2, negative 3. If x is 7 over the square root of 3, then y is, this is a job for a calculator, but we'll find that it's one of the square roots of 64 thirds. So it's plus or minus 8 over the square root of 3. So that gives me 7 over square root of 3 and 8 over square root of 3, or 7 over square root of 3 and negative 8 over square root of 3. These are unpleasant numbers, right? We could get decimal approximations if we liked those better, but that wouldn't be any more pleasant. Our last possibility is x equals negative 7 over root 3, which gives us y equals, again, plus or minus root 64 thirds, which is plus or minus 8 over root 3. So that gives us 2 more solutions. Negative 7 over root 3, positive 8 over root 3, or negative 7 over root 3, negative 8 over root 3. It looks like this system has 8 solutions. Is that really true? Are all of those actually solutions to this system? We did a bunch of strange things in the process of solving that. Did any of those have the potential to introduce extraneous solutions? And how would we know if they actually did? That's what we're going to see in the next video.